Welcome students, welcome to the first lecture on mathematical reasoning. In this lecture and in subsequent few more, I will be explaining the concept of mathematical reasoning and also solve a few problems on this topic. This is a part of CBSE class 11 syllabus and also of JEE mains, but more importantly in future, if you follow computer science or higher degree of mathematics or even in electronic circuits, you will find ample use of these concepts. So, what is reasoning? Reasoning is the process of forming conclusions judgments, inferences, from given facts or premises. This is something, a definition that is taken from dictionary, and you may not be easily understanding what actually it says. So, I will be explaining this with examples. Say for example, consider Alice is good in mathematics. This is one fact that is given to us. Another fact is this problem needs good knowledge of mathematics to solve it. Suppose this is the premise or this is the facts that are given to us. What can we conclude from there? We can conclude from there is that Alice can solve this problem. Is that right? Because Alice is good in mathematics and this subject needs good knowledge of mathematics. Together from these two facts, we can infer that Alice can solve this problem. So, this is a very simple reasoning that we human beings can do easily from the given facts. Sometimes of course, it is not so simple. So, let me give you some example. Say suppose we write root 2 is an irrational number. Root 3 is an irrational number. Given these two, can we infer that root 4 is an irrational number? You have seen your classes on inductive reasoning that if something is true for 1 and 2, say 2, 3, then we can infer from there about 4, or in general if something is true for 1, 2, 3 up to n, then you can infer it for n plus 1. So, by inductive reasoning, if one tries to come to the conclusion that root 4 is equal to 2 is an irrational number, that is not correct, right. So, everywhere this type of reasoning does not work. In a similar way, we can say that root 2 square is equal to 2 is a number, right. Root 3 square is equal to 3 is a number. Therefore, can we say the square of an irrational number is an integer? No, that will be a wrong reasoning. Therefore, we have to be careful when we want to reason about something given a set of facts, what is the conclusion that we are deriving, we have to be very, very careful about that one. So, in mathematical reasoning, we try to put this reasoning process into a mathematical perspective. Because reasoning is something that we human beings are always doing in our daily life. Say for example, suppose the sky is cloudy and you have to go out. So, you may decide to take an umbrella. This is a simple reasoning that we do if we are going out of home and we find that the sky is cloudy and it might rain soon. In a similar vein, suppose you are going to mountains, even in summer, you will be taking with you a sweater or jumper, so that you do not catch cold when you are in the cold place, right. So, these are the types of reasoning we are doing and this makes human beings superior. Now, the question is, how can I do it mathematically? And why do we do it mathematically? Because if you want to write a computer program to do some reasoning, you might have heard of robots, etc., who are expected to behave like a human being in accomplishing certain tasks. So, how can they do it? They have to reason. So, there must be a reasoning formalism within the system that will help us to think and solve a problem. Therefore, at the crux of the problem of reasoning is to express these type of statements or these type of sentences that I have written with respect to with some mathematical notation. Say for example, let me take the sky is cloudy. It may be correct, it may be wrong. So, this sentence can have two truth values it is true or it is false. How does it help us? So, if the sky is cloudy, then I take an umbrella. I write it in a different way. If the sky is cloudy, is true, then I take an umbrella. Is true. What does it mean? It means that if the sky is cloudy, then I take an umbrella. So, I am writing it in a different way. If the sky is cloudy is true, then I take an umbrella. This sentence is also true. Or in other words, if the truth value of the sky is cloudy is true, which we denote by 1, then I take umbrella. It also has a truth value 1. It is not mandatory that all such statements will have truth value 1. So, if some statement is false, then we give a truth value denoted by 0. Or in other words, if something is true, we give it a truth value is equal to 1. If something is not true or false, then we give a truth value equal to 0. All right. So, let me give you some examples. Example sentences when truth value is false. Suppose there is a sentence, the February month has 31 days. We all know that this is not correct. Because February has 28 days in general and 29 days if it is a leap year. Therefore, the above statement it has truth value is equal to 0. I give you some more examples. All primes all prime numbers have only two divisors, 1 and the number itself. Its truth value should be 1, because this is true. What about if I write all prime numbers are odd numbers? We know that it is true except for the number but we are allowed to give only two values, two possible values, either 1 or 0. Therefore, if we look at the sentence all prime numbers are odd numbers, this is not correct, because there is a number which is prime, but that is not odd. Therefore, this number will have truth value false or 0. Okay? Now, the next thing is, can we assign truth values to all sentences? The answer is no. Example: interrogative sentence. What is the sum of 7 and 17? This is a question that is being asked. Therefore, we cannot assign any truth value. Similarly, exclamatory sentences. Say for example, wow, India has won. Here some person is excited that his or her country has won and giving that expression. We cannot assign any truth value or consider imperative sentence. What is an imperative sentence? When you are ordering somebody or asking somebody to carry out some work. Say for example, please add 389 to 5746. So, you are asking somebody to do the addition and give you the result. It cannot have any truth value. So, in our day to day life, we will be coming across many such sentences where we cannot assign any truth values to them. Therefore, when we are looking at mathematical reasoning, we look at sentences which are assertive sentence, that is something is being stated about something and we can assign a truth value to it. Okay. Now, I will give you examples of many sentences where we actually cannot assign any truth values, or there will be ambiguities when we try to assign such values. So, give you some examples. all months have at least 28 days. It is correct, because all the months will have at least 28 days. Therefore, this is true. All months have at least 40 days. We know that it cannot happen. A month can have at most 31 days. Therefore, this is false. What about this? All months have at least 31 days. We know that there are months having 31 days. So, it appears to be correct, but that is not true. Look at this word all. This is a statement with respect to all the 12 months in a calendar, and therefore, this is incorrect. Therefore, this also get a truth value equal to false. But if I write some months have then it is correct. I hope you understand the difference between this statement and this statement. These two are basically different statements, and therefore, we can see that this has a truth value t, but this has a truth value false. What about this? This is a statement or a sentence, this month has 30 days. We cannot assign any truth value. Because it depends upon the particular month we are in. But if I write that April has 30 days, then this is true. Or January month has 30 days, then it is false. In a similar vein, suppose we write Ram is tall. Apparently, it has a truth value true or false, but that is not correct. Because tallness as an attribute is relative. A person with height 5 feet 8 inches is tall for a person of height say 5 feet 4 inches, but he is not tall for a person of 6 foot 1 inch height. This is a relative term, and therefore, we cannot say Ram is tall is true or false, but say something like sentence Ram is 5 feet 8 inches tall. We can assign a truth value to it depending upon whether the above is correct or not. All right. Let us consider some more such sentences. The square root of x is greater than 1, where x is a real number. We cannot assign a truth value here as x is not known. But if x is known, then we can. Example, x is equal to 2, then the above is, then say square root of x greater than 1 is true if x is equal to 0.5, then square root of x greater than 1 is false. Similarly, tomorrow is Friday. We cannot assign any truth value. Its truth will depend upon what is today. If it is a Thursday, this is true. If this is any other day, then this is false. Okay? Now, let me talk about another example. Suppose it is given any number if multiplied by 2, any number if multiplied by 2 will give an even number. Then from here we can infer seven multiplied by 2 is equal to 14 is even number. 351 multiplied by 2 is equal to 702 is an even number. 9836,952 into 2, I do not know what the product is immediately, but what I know that the product is even number. Even though I do not know the answer immediately, I can say from the given fact that any number if multiplied by 2 will give an even number, I can say that the product 9836952 multiplied by 2 is going to give you an even number. Okay? Now, suppose we further assume that if a number k is multiplied by n1, n2, nk, np, then the multiplication will be carried out k into n1 into n2 into np is equal to k. I will first multiply by n1, then that product I will multiply with n2, like that I will go, and finally, I will multiply it with np. Let us assume that this is the way we will carry out multiplication successively. Now, consider a number to be multiplied by 6. Now, 6 we can write three into 2 and 2 into 3. Therefore, suppose consider 7 cross 6, which is equal to 7 cross 3 cross 2, which is equal to 7 cross 3 cross 2. I do not know whether it is even or odd, but I know that since it is being multiplied by 2, therefore, this is going to be even number. But given the above premises, if we write seven into 6 is equal to 7 into 2 into 3 is equal to 7 into 2 into 3, then we cannot say it is even or not, because whether the above is even, as we know 7 cross 2 is even, but we do not have any knowledge whether when a number will be multiplied is multiplied with 3, then it will be even or odd. Therefore, 7 multiplied by 2 multiplied by 3 we cannot say. But if at the beginning we start with a sentence, any even number when multiplied by any other number the product is even, then we could say seven cross 2 cross 3 is even as 7 cross 2 is even. So, when we look at things mathematically, we will have to be very careful. We have to see what exactly the fact is given to us, what is the statement, and based on that whether we are able to infer the truth value of some other sentence or not. So, that is the entire purpose of reasoning. Given a set of facts, what we can deduce from there. Thus, it is not an inductive form of reasoning, rather it is deductive. As I have given you example that simple induction may not work, as I have shown that root 2 is irrational, root 3 is irrational, does not mean root 4 is irrational. Okay? Now, the question is, therefore, what type of sentences we are going to accept for mathematical reasoning? A statement is said to be mathematically acceptable if we can assign a truth value either true or false to it. So, if we cannot assign the truth value, then we are not able to accept that as a mathematical statement, right, and therefore, we can use it for any subsequent reasoning. So, I hope that I could make the concept clear. There are sentences. Sentences can be of many types only. So, basically what I am saying, sentences can be of many types. Only assertive sentences can be mathematically acceptable. Not all assertive sentences as there may be ambiguity in the premises. So, in such cases we cannot consider it for logical reasoning or mathematical reasoning, otherwise we can subject it to subsequent reasoning. Now, a first step towards using a sentence, a statement for further reasoning is to generate new statements given a statement which is either true or false. How do we generate new statements out of it? We will discuss two ways. One is through negation, other is through compounding a number of statements. By the way, by a statement I mean any assertive sentence to which we can assign either true or false value. Okay, friends, I stop here today. In the next lecture, I shall start with how given facts we can construct new facts out of it through negation or through compounding it. For compounding, we need some connectors. Typical connectors are and or, and also we look at something called implication. Say for example, if the sky is cloudy, that implies that I will take an umbrella. Okay? So, what is going to be truth value to the whole compounded statement that if the sky is cloudy, then I will take an umbrella. How to get truth values of such statements? That is the most interesting thing with respect to mathematical logic. So, in the next class, I will start with that. Thank you so much.